Хорошо, спасибо. Good morning. Good morning. I can't see anyone except you. Let me see. I will post this to everyone and I will be very, very angry after. Так. Decided to give me a favor, being present on my lecture. So for all present, I will repeat again then. For you to understand, I'm not just your chemistry teacher, I'm your vice dean as well. Those who made WhatsApp chat, WhatsApp group, the one you write your complaint and your question, the one who give you your timetable, me, this person. And that's why now I can see how you attend classes. Even few students who present being late for few minutes, but late. No, so what should I expect? There's supposed to be 7 groups present. Okay, I'm very, very disappointed and it's very bad start, guys, trust me. It's very bad start if you start education, being late practical classes, ignoring your teachers, disrespecting them, and so on. And I don't understand. Now they write, ma'am, yes, it's clear. After I posted information that we have lecture 9:50. 9:50 lecture, now 6 minutes past. It's the same that lecture hall, I'm standing there in front of you, and there no one, and now you knocking the door and saying, good morning, ma'am, can we enter? 7 group, that's mean more than 100 students. More than 100 students must sit in a lecture hall. So what can I say? I'm very disappointed. Okay, I will start. Next time there will be bad list made for all students who late and for those who will not come. So before to start to give information, I want to give you something not in chemistry. Again, let me introduce myself. I'm Ekaterina Dmitrievna Melnikova. I'm chemistry teacher, associated professor, PhD, but I'm vice dean as well. So that's why the person who control your attendance and will complain to your parents because of now I have such chance about you disrespect other teachers and have no anxious to study. So after I remind you that you need to attend practical classes and lecture, you decided to give me a favor. Yourself you ignore. I will ask previous teacher, psychology teacher, did you miss his lecture or not? And for you to understand, I can see here the diagram and I can see the chart. I can see everyone surname and I can see how many students are added, how many late, everything. I have diagram here. So you have no free attendance at all. No free attendance. You must attend all practical classes and lecture. Online education, it's not a self-study. Online education means according to your timetable. You must attend classes. Class starts 9:50. Respect your teacher and come and be here and wait for teacher starts translation. What is this? I entered, there one student came, all other waited till I remind them. So 2021, Sriman Muraseti, my student, I'm your teacher. I'm your practical class teacher, I'm your lecturer. I'm your vice dean, and you late for so many minutes, almost 8 minutes. You understand? It's disrespect. So that's why I hope it's the last time I heard from others, from other teachers, complain about your behavior. And if next week you will late even 1 minute on my lecture, I will not allow, I will block your name here and will write complaint to your parents. Or maybe you will insist to talk to them because of now I have chance to talk to them online. Using Discord and Skype, I can do this and I will as a vice dean. So now let's come back to chemistry. So I'm so disappointed in your behavior, second division. I'm so disappointed as a vice dean. I expected different and I'm very disappointed. And they are still adding themselves and saying good morning. It's not good morning. It's not good. Maybe morning, but not good. Kritika Tiwari, it's a shame you late 10 minutes almost. It's a shame. Lakshmi, it's a shame. Won't repeat again, we'll see. So unfortunately, as we have lack of time and you started later, and you start, you know, November 1st supposed to be, but it was almost December already, and it's not September 1st even, that's why you have lack of time twice per week classes, but lectures once per week. And that's why not every lecture you will get information, not every topic for. I choose some, and there are how many? 8 lectures will be only, supposed to be 17, but will be just half because of lack of time. So chemical kinetics and chemical equilibria, today's topic. Their theory, thermodynamics, I decided to give you chance to be ready yourself because of they're only necessary to read books and answer. some questions. So information was posted in Moodle. My groups I posted for you in Discord. The book, there's few pages for self-study, and that's why class time you should answer teachers' questions. So for chemical kinetics, what should we know about? There are two sides of same coin. There are two parts of chemistry dealing with the chemical processes, very essential some. It's a chemical thermodynamics and chemical kinetics. The first one, chemical thermodynamics, can answer essential question we ask ourselves when we start to any experiment we're going to start, whether this reaction is spontaneous or not under particular conditions. So whether it's spontaneous or not. But even if reaction is spontaneous, if you remember, some students already passed this topic, to be spontaneous, reaction supposed to be with a delta G less than 0, negative value of Gibbs free energy change. So, even if reaction happen with a lower than 0 delta G, it can be such slow that lifetime not enough to see any result. So such reaction is same useless as the one not happen at all. So that's why to know chemical kinetics, the rate of chemical reaction is well important and sometimes even more important than to deal with the value of thermodynamical functions. So let us start. So what do we know about chemical kinetics? Chemical kinetics are not just kinetics, it's a branch of physical chemistry which deals with the rates of chemical reactions and their mechanisms. For chemical thermodynamics, it wasn't important to know how reaction is reached. There was important to know initial and final state of the system, but not the way to reach the state. For chemical kinetics, it's essential information, as there are number of steps limiting the final chemical reaction rate. So, chemical reactions, according to where the process happens, can be classified into two types. Homogeneous, for example, reaction of nitrogen with a hydrogen forming ammonia. So why it's homogeneous? Because of reaction aggregate state, reactants aggregate state. Now we're talking about one direction reaction, one arrow forward. Concentrate on this, not reversible, just one side. So reactants important for chemical reaction rate, their nature and their aggregate state. Take a look, both nitrogen and hydrogen are same aggregate state. That's why it's homogeneous. Doesn't matter what products. For example, if there we have reaction between two salts in aqueous medium, it's a test reaction to identify silver or chloride ion, doesn't matter. So both of them aqueous, it's ionic reaction. The precipitate is formed, white precipitate, but it will not affect homogeneity of reaction. And this happened with the product already. But the nature of reaction depends on initial substances, their reactants aggregate state. Homogeneous happen in all volume. Heterogeneous, very sensitive to the surface, and their reaction happen on the surface of one of reactants. For example, in this case, it's a carbon solid and oxygen gas. Reaction happen on carbon solid surface. That's why, as I told you just now, it's quite sensitive to the surface area. The mass here, it's not information we need to know to decide how far the chemical reaction is. Because of same mass, carbon, for example, piece of charcoal, this big piece of carbon can be oxidized small. It will oxidize, burns, for example, with a slow rate and long period of time producing some heat. But if we will take same mass but powder, reaction happen with explosion. That's why for heterogeneous reactions, surface area, it's one of the very important factors. So what is the rate of chemical reaction? When we deal with a chemical reaction rate, we're interested in a change of concentration of substances per unit time. Tau it's a time, delta tau it's a time interval. It can be second, can be minute, can be hour. not necessary to convert. Change of time, always positive value. Change of concentration, capital C symbol means molarity. That's why the unit is mole per liter. So change of concentration of reactants or products. That's why here plus minus before the ratio. Rate never negative and never zero. Negative rate never happened. Rate equal to zero means that there are no reaction at all. No change in concentration, no change in structure. So that's why only positive value of rate. But we can measure rate using information from reactants. For example, for some hypothetical reaction, A forming B. So how to measure the chemical reaction? We can see how substance A losing concentration, the lowering of concentration of initial substance A. So we see that with time, concentration becomes lower because of second smaller than first, but rate can't be negative. That's why we add negative sign before the ratio to get positive value of rate. So the easiest way, we measure the lowering of concentration of substance A with time, but same rate substance B is produced. A lowering, B rising, their concentration is rising or lowering with the same rate. That's why the change of concentration of product also can be used to measure the rate, not to affect the rate, please, but to measure it. So change of concentration for product is positive value. Delta tau, the time interval, is positive value. So that's why rate is positive. We need no sign before. There are a huge number of factors affecting the chemical reaction rate. So first of all, nature of reactants. And here what we can say. Nature can't be calculated ever. There are no formulae, no laws describing how nature effect on chemical reaction rate to give exact value. We have just general information from our life experience. We just know that homogeneous reaction more often happen, more often, here very important to use these words, more often happen faster than heterogeneous. Because of heterogeneous happen on the surface, that's why it's sensitive to the surface area. But it's not always. For example, some homogeneous reaction happen very slow. Some heterogeneous happen with explosion, like for example, sodium and water. So we know that ionic reaction quite often reacts faster than molecular, but it's not always. And so on. So nature, information we use to predict what we should expect using something from our life experience for similar reactants. For example, if we need to start reaction of bromine with alkane, halogenation, we know that chlorine react with the same substance, for example, methane. It's react with explosion because of free radical substitutional reaction. Okay, so bromine and chlorine, same group elements. We can expect that this reaction also should happen fast. And then we check, is it truth or not? But we're already expecting for something. This is nature. Second important factor, it's a concentration. It's a second because of it's useless to deal with the increased concentration affected by temperature if we know that nature of reactants will not allow these substances to react somehow. So concentration, I will show you the formula then. Let us give the list of factors affecting the chemical reaction rate. So concentration of reactants only, not products. Products can be used to measure the rate, but not to affect the rate. Pressure, but only if there any gas participate in a chemical reaction. Reactants, one at least supposed to be gas. Activation energy. What is, I will tell you then. It's essential factor, essential because of from all these mentioned, this factor, the highest affecting on the chemical reaction rate. The best effect. Temperature. Some students know this factor much better than all other factors. Activation entropy. Students who pass thermodynamics know the word entropy means disorder or redundance. So activation entropy, now we will mention here is one of the factors affecting the chemical reaction rate. And last but not least, it's the presence of catalyst. So let us start. Nature, I told you how to affect the chemical reaction rate and concentration of reactants. So what we know here? Mathematically, the concentration effect on the chemical reaction rate described with the rate law or law of mass action. The rate law states that rate of chemical reaction is directly proportional to the product, mathematical product of the concentrations of the reactants at the stationary temperature. Just for you to understand that if we're trying to understand any factor effect, all other factors should be taken as a constant. So want to understand concentration effect, don't change temperature, pressure, and other factors. Then if you need to understand how temperature will affect the chemical reaction rate, concentration should be taken as a constant. So let us try to describe this rate law mathematically. What some chemical reaction, again hypothetical, A plus B forming some product C and D. This reaction must be balanced. Stoichiometric coefficients here, small a, b, are indicated with the color blue. This is balance coefficients, just to indicate amount. As you know, mass can't disappear. So what we can say, being directly proportional. That means there's supposed to be proportionality constant. It's known as a rate constant, small k symbol. So rate is directly proportional to the mathematical product of concentration of reactants in power of orders of the reaction with respect to A and B. Please, orders can be equal, can be not to stoichiometric coefficient, but it's not the same thing. Orders equal to balance coefficient only for elementary step reaction. But when we see the chemical reaction equation written, we have no idea what there happened deep inside. The mechanism is known for by experiment. So that's why we can't say, are they equal or not? That's why orders we can determine only experimental way. Orders can be integer, can be not, can be negative. And that means we increase concentration of substance, but chemical reaction rate becomes slower. Can be zero order for some substances. What does it mean? That means concentration of the substance not affect the rate, but it must be present. So different mechanisms explain why some substances even can lower the rate, but essential for this reaction happen ever. So understand this, X and Y are found experimental way. They must be given, or they are in a task must be mentioned that this is elementary step, that there are no intermediate, just transition state. So no intermediate, we can't say. This information experimental way measured. How to find the overall order of reaction? It's just the sum of orders with respect to each substance. Every order, for example X, what is the physical meaning? The physical meaning of this order, it shows for how many times rate increase if we increase concentration of this particular substance. So X shows how concentration of A affect the rate. Y shows for how many times rate increase if I will increase concentration of substance B. Concentration symbol can be capital C. It's a mole per liter, more often molarity we use such symbol. But here in kinetics we start to use new symbol, square brackets. So symbol A, letter A, written in square brackets also means moles per liter. So the physical meaning of rate constant. It's a rate of chemical reaction if molar concentration of every reactant equal to 1. Doesn't matter what orders here. If concentration 1 mole per liter, power x, any x, it will be equal to 1. In such case, rate constant equal to rate. Due to what is the order reaction, rate constant can be different unit. Rate always same. It's a change of concentration per time. Difference between different chemical reactions just can be in a time interval. If we know reaction is fast enough, we use seconds as time interval. If reaction is slow, we can use hours, sometimes even years. But mole per liter change for chemical reaction rate. So concentration mole per liter, but power different. So that's why rate for first order, now take a look, if there will be zero order reaction, overall order 0. In this case, power 0, it's 1, and doesn't matter what concentration, rate equal to K, and has same unit, mole per liter time. First order reaction, rate constant symbol per time, per second, per minute, per hour. Second order will be liter per mole second. Third order, not often happen, but happen, it will be liter square per mole square second. So depends on overall order of chemical reaction. For heterogeneous reaction, as I told you, a reaction happen on the surface of the solid or liquid substance if we deal with a gas-liquid reaction. In our case, I took solid. So what do we know about? It's not a concentration, the factor describing this substance. We know its standard state means that this substance should be pure. This is it. Surface area, it's already happened. It's a part of the nature. So that's why in rate law, this value is absent. We accept that surface area in the beginning of the chemical reaction is fixed, and it starts during the chemical reaction, it's already will not change. The reaction starts. That's why surface area in a rate law accepted as 1. And our rate will depend on only concentration of reactant, which concentration can be varied. Now, for example, gases or aqueous solutions, the concentration can be different. That's why it can affect the rate in a rate law. Next factor is pressure. What we know, I hope you know very well, that pressure and concentrations are directly proportional to each other. Pressure, P symbol, small p, partial pressure of the gas, is equal to concentration, molarity, mole per liter, times gas constant, which is 8.31 joule per mole kelvins, and temperature Kelvin scale. So, don't forget to convert. If they are not equal pressure and concentration, but directly proportional, we can use information, the value of pressure instead of concentration, but you should understand the rate constant becomes different. So if we put here concentration, it's K equal to Ca power x. No brackets here, not essential. So if we want to use partial pressure instead of concentration, we need to take concentration. So what is pressure? So instead of concentration, it's a pressure divided RT. P over RT. That means rate constant will be nu. It's still constant because of gases constant and temperature not changed during this factor pressure effect. So, but it's different from the rate constant for concentration in a rate law. But both of them can be used. And the rate value will be absolutely same. For example, if we deal with a reaction between carbon solid and carbon dioxide gas forming 2 moles of carbon monoxide, chemical reaction rate will depend on only concentration of carbon dioxide, as a surface area can be accepted as a constant. It will not, it's in nature, it will not affect during the chemical reaction. It's already initial information for us. So or pressure or concentration, but different rate constant. So how to determine rate constant? In experiment, I hope it's clear, because of the physical meaning. We take concentration 1 mole per liter, or pressure 1 equal to 1. So when we measure the rate constant, we measure rate, and as a result, we can say that this is rate constant. The next factor, activation energy, capital EA is a symbol, as an energy kilojoule per mole unit. What is energy is? It's an extra energy needed for reactant molecules to be able to react chemically. What does it mean? Our substances going to react with each other. They exist, they have exact structure, they have internal energy, heat contents, they have bonds with exact bond nature and what energy should be destroyed to form something new. For them to react with each other, they should lose this stability. What way? Absorbing heat from surrounding. What is heat? Where this heat goes? This heat goes to destroy all bonds and initiate formation of new. Always, any chemical reaction needs some energy from surrounding. That's why activation energy is such great limit for chemical reaction rate. If a reaction needs huge value of activation energy, in surrounding these reactants may not find, and the reaction will not proceed, even being with delta G negative. As higher the activation energy, as low the rate of chemical reaction. It's kind of barrier our molecules or ions should pass through to be able to react chemically, to form new products. For you to understand how sensitive our chemical reaction to activation energy, here I put the example, just 20 kilojoule. You know that we have one of the not the weakest, one of the weakest bonds we deal with, the hydrogen bond. The hydrogen bond is very weak, one from 8 to 20 kilojoule per mole energy just. So see such weak bond, 20 kilojoule, such value is quite small, but the rate increases 3,000 times. So to change activation energy, if we can do this, we will affect chemical reaction rate much more effective than other factors do. Any chemical reaction, to understand what's activation energy, where it goes exactly, we need to understand how, what process, what steps every chemical reaction passes. So initial substance, our reactants from flask, we mix them and absorbing some extra heat from surrounding activation energy, their transition state is formed. Please, not intermediate, it's a different thing. Transition state or activation complex. And only after this, final products appears. How this looks like in diagram. So activated complex or transition state, it's an aggregate of particles participated in the chemical reaction in which breaking of old and formation of new bonds occurs simultaneously. Time interval of this activated complex exists. It's almost, we can't even say how small, 10 power negative 12, 10 power negative 13 seconds. So we can't register it, we can't even determine it appears, fix with a very sensitive method. We can't. We know that it's something happened during change in energy. We can predict formation of some transition state, but what we see, take a look, heat content never zero. Heat contents enthalpy of substances at some positive value. They have some. So, for example, they are reaction A plus B forming some product AB, additional reaction. So they have A and B, they have some initial heat contents. For them to react with each other, they are absorbing some value of activation energy from surrounding barrier. When this process happens, absorbing of this heat, all bond destroyed till no more left. This is transition complex. There are no substance to be indicated. No, it's that's why not correct to use this word intermediate. As intermediate, it's a real substance. due to mechanisms formed, and if they are long-lived enough, they can be even, a reaction can be stopped in this. Their concentration can be determined. Their presence can be fixed with chromatography, for example. Transition state, not. It's too short. But it's a place where no bonds left, no bonds formed yet. And when from this top of energy, our molecules or ions are formed during formation, energy lowering. So our transition state, there are no bonds yet, losing, return this extra heat was absorbed in surrounding. And if it will give more than took, the reaction is exothermic. The final heat lower than it was, delta H will be negative. If it will give back less than it was, so somewhere here will be the value of heat contents for the product. So this is endothermic reaction. But these values of final always lower than the heat, the activation energy. Next factor, students knows, I don't know why, but better than all other factors, it's a temperature effect. And here we can deal with the law and rule. The more often we deal with the Van Hoff's rule, 1884. It states that with increase of temperature on each 10 Celsius, the rate of homogeneous reaction increases in 2-4 times. The average is 3. Not 2, not 4. From 2 to 4, what it depends on? It depends on nature. It depends on nature of our reactants. And this value, is it 2, is it 4, is it 3, can be only experimental way measured. What is this factor? This 2-4, it's a gamma factor. It's a temperature factor of chemical reaction rate. We search for experimental way. What way? We change temperature, measure how many times rate increases, and mathematically we can calculate what is the gamma. K1, K2 are rate constant. A temperature can be Kelvin scale, can be Celsius, doesn't matter. In all cases, delta T is same value. So why here can be written rate second equal to rate 1 times gamma, power delta T per 10, it's a power. It's not equal, it's a power. So, but usually, as I told you, when we trying to understand, when we do any experiment to predict exact factor effect, like temperature in our case, other factors should be constant. That's why if we take 1 mole per liter concentration for our reactants, rate equal to rate constant. And that's why instead of rate, we can put here K, the rate constant value. So, what is important? If we will increase temperature 10 Celsius, delta T equal to 10. 10 over 10 is 1, and rate K2 over K1 will show that rate will increase 2-4 times, as 2-4 it's a value of gamma. For exact reaction, exact value, but for rule enough to say from 2. If I will increase temperature 20 Celsius, delta T equal to 20, 20 over 10, we will get gamma power 2. And the rate will increases 2 power 2, that means 4, to 16 times. 4 power 2, 16. If I will increase temperature 30 Celsius, so we will see that there will be 2 power 3 to 4 power 3. That means 8 to 64. Just 30 Celsius, 30 Celsius, enough in some cases to increase temperature, chemical reaction rate 64 times. As you see, very sensitive. Except Van Hoff's rule, to determine rate constant, we can use Arrhenius equation. This is the way to determine rate constant if we're interested in it, and we can't measure the rate, the concentration change. So, its Arrhenius constant depends on a huge number of different factors except temperature. A is found experimentally when we know their rate. E it's a base of natural logarithm. Activation energy is also depends on nature of our reactants. It can be affected, but first of all, nature is a limit of activation energy. RT, we know it's a gas constant and temperature, Kelvin scale. So if we know activation energy, already found by sensitive methods, and H for reaction is constant for any temperature, we can determine rate constant. Or if we know the rate, we can determine activation energy, for example. Arrhenius equation we will deal with in biochemistry for some biochemically important reaction rates. More often we deal with the Van Hoff's rule. Activation entropy. As I told you, it's a entropy, thermodynamical function, means measure of disorder, redundance. So why it should be mentioned here? Because of when we deal with such reaction like substitutional reaction, and reaction happened, for example, with between organic with a higher number of functional group, it's very important that not all collisions are effective. Additional, substitutional reaction happen, they're supposed to be collisions. For elimination reaction, for example, this factor is 0 because of its decomposition. There are no collisions at all. But for additional, for substitutional, it's very important proper orientation of molecules in the moment of collision. And as higher the branched the formula, as higher number of functional group in organic chemistry, there higher number of non-effective collision possible. As example, I took here aldehyde reaction, reactive and non-reactive collision. For example, additional reaction between aldehyde acrolein and but-1,3-diene. From 4 possible collisions, just 1 effective. As higher the number of non-effective collisions, as higher the activation entropy. Where these effective collisions, selectivity you can remember from biology. For reactions with enzyme, maybe you remember there was towards key and lock. This means only 1 collision when their proper orientation will be useful, effective. And the last, as I told you in this list, but not least, it's a presence of catalyst. Very important to understand that the word catalyst doesn't mean that it will increase the chemical reaction rate. Catalyst means substance that change the rate of reaction by changing the activation energy. That's why catalysts are so effective. That's why in industry and not only, we're searching for catalysts because of it's the easiest way, even in mild condition, like in our body. Almost all reactions biochemical activated with biochemical catalysts we know as enzymes. So because of catalysts, they affect the activation energy. That's why. So catalysts can be positive, can be negative due to what they do with the chemical reaction rate. And very important to understand one more thing, that catalysts are not reactants just. They are participants. They are not increase or decrease without chemical reaction. No, they react with our reactants, but they are regenerates after. They are not forming a new product. That's why catalyst we write above arrow to show that this will not form a new substance, but they participate in a reaction forming intermediate. Real substances really can be fixed and sometimes even separated from the reaction mixture. We can observe their formation. Positive catalyst and negative catalyst. Positive catalysis means reaction becomes faster. More often we deal with negative catalyst, negative catalysis. It's a slowing down the reaction. So such catalyst we know is inhibitors, but very often in book you can read the word catalyst, meaning that it's increase the chemical reaction rate for short term. Catalyst inhibitor, but it's not chemically correct. It's not correct. We need to insist, is it positive or negative? So catalysts can be also classified. Types of catalytical reaction, more correct to say, can be classified into homogeneous and heterogeneous due to where this process happen. Homogeneous, that means catalyst is the same phase. It's a gas or solution, aqueous medium, as a reactant. So reactants are gases and catalyst is gas. It's very effective because of homogeneous, not sensitive to surface area, but recovery is difficult. It's hard to separate catalyst from the product then. Heterogeneous, in this case, much more easier to separate because of heterogeneous catalyst. Reaction happen on the surface of the catalyst. Catalyst in a different phase than reactants. They are gas, catalyst is solid. For example, hydrogenation reaction of some unsaturated alkenes or alkynes. So we know with hydrogen they react quite readily. If we will use, not readily, it's a stressful reaction, but if we will use nickel or platinum or palladium as a catalyst, higher temperature, higher pressure, all these factors supposed to be, and reaction happen on the surface of catalyst. As example here, same reaction, decomposition of hydrogen peroxide. So with a different catalyst mentioned. Manganese dioxide or manganese Roman number 4 oxide. It's a positive catalyst. Reaction becomes faster, but heterogeneous reaction happen on the surface of this oxide. Negative catalyst. It's a second one. It's aqueous as well as hydrogen peroxide. Reaction becomes slower. Sometimes we're interested in slowing down the chemical reaction rate. For example, in our body, the inhibitors of something like proton pump. So if allergy, antihistamines we use. Some of them predict releasing, protect, not allowed to release more substances. We will study soon this topic. Histamine substance released, and we use substances predicting its releasing, slowing down it. So negative catalysis, it's quite useful also. So homogeneous, it's also aqueous. That's why it's very hard to separate water, the product, and oxygen evaporates. So that's why if we need to produce oxygen, we will collect it. But for other cases, if they're both stay in aqueous medium, I mean both products, it's hard to recover. So the mechanism of catalytical reaction looks like this. For example, there we have any chemical reaction, A plus B forming, let us write like this, A plus B, I will write in a chart, forming something like AB. So without catalyst, reaction happens slow. We want to increase the rate of chemical reaction. We add catalyst. What catalysts do? So without catalyst, activation energy quite higher. We want to make it be smaller or bigger. Let us see what can we do. Catalyst symbol capital K. So what catalysts do? Catalysts can react with one of reactants better than they react with each other. This is the idea. So for example, substance A react readily with our catalyst, forming intermediate, this is important, intermediate with own transition state, intermediate AK. AK, it has own activation energy, the value. So after this, so as you can see, so we have product. It's intermediate. After this, our AK can react with a second reactant B, forming also transition state, and need activation energy to be absorbed from surrounding. It's a second value. EA2. So our AK, I write in a chart, forming product B, the B product, reactant, I'm sorry, forming our product AB, and catalyst regenerates. It stays same as it was. So take a look, AB plus K. So if sum of activation energy for these two reactions with catalyst will be less than activation energy without the catalyst, so that means reaction proceed faster, and this is positive catalysis. If their sum of activation energies A1 and A2 will be greater than activation energy without catalyst, reaction becomes slower, and this is negative catalyst inhibitor. There are two substances. I don't know why students making mistakes when they are trying to understand what this. It's anti-catalyst, or we know them as catalyst poison. It's not a catalyst. It's a substance that lowers catalyst activity. With our reactants, the substances never react with each other. They react with the catalyst blocking the surface and not allow catalyst be active. Catalyst poison, usually heterogeneous catalyst, very sensitive to catalyst poison. So promoters, what they do, substances that intensifies catalyst activity. That means they help catalyst to be more active, but also they not react with the reactants themselves, just with the catalyst. That means anti-catalyst, promoters, they are not catalysts. They are the most interesting from the point of catalysis substances we know as enzymes are selective catalysts. One biochemical reaction can be activated, can be increased, the chemical reaction rate of it with the help of one enzyme. Almost for every reaction, we have own enzyme in our body. They are proteins nature, that's why very sensitive to any change of any factor like temperature, pressure, and pH. So mild condition, this is unique situation. Temperature is quite low. We have in our blood, for example, 37. Pressure, our body pressure, osmotic and pressure, uh, atmospheric pressure, no, the air we breathe, right? It's a partial pressure of the gas. And acidity, we have mild condition and we very sensitive to change in pH, in some change of pH of blood, just 0.6 value will cause denaturation of proteins. Patient will die because of acidosis or alkalosis. So that's why enzymes acts very mild condition. We can't use temperature, pressure, and acidity, basicity, no, I mean pH change to intensify there. We can just make worse. And that's why they're so unique. So from one direction reaction, when we deal with a chemical reaction rate for irreversible case, we have reactants forming products. Almost never reactions happen completely to the products. So for 100 reactants react, forming 100% of products, almost never happened. So usually something left among reactant because of not enough conditions, not enough factors to make this reaction happen completely. Can happen, but can be cases our products can react back. So such reactions we know is reversible. That means one, the reactants we will find in a reaction mixed, and not because of reaction not complete, are because of new reactants formed because of backward process. Two reactions, forward and backward, proceed same moment. And that's why their equilibrium is reached. What is chemical equilibrium? It's a state of system when the forward and reverse, that means backward reaction rates are equal to each other. Not only both reactions happen, but even with the same rate. For homogeneous reactions, what we know about? So that means we have here two rate laws. Rate law for forward, where rate is directly proportional to the concentration of reactants, and rate for backward. Rate for backward means directly proportional to the concentration of reactants, but they are products for forward. That means we have here two reactants in left side for forward reaction and right side for backward reaction. That's why chemical reaction rates, here we have two, and they can be, equilibrium can be shifted. It's dynamic. Affecting the reaction mixture, we can affect the chemical reaction rate, knowing the factors we mentioned just now, but these factors can affect these two reactions different way, like temperature. It can affect both forward and backward, but not in the same value. For one, it will increase 2 times, a second one can be increased 4 times. And that's why equilibrium will be shifted. What's mean shifting of equilibrium? That's mean from the point where both reactants rates becomes equal, we've got the point where one of the rate bigger than second. We say an equilibrium shifts forward, that means forward reaction faster than backward. If we say an equilibrium shifts backward or to the left, that means backward reaction faster than forward, but it's dynamic. Changing the factors, we can change the equilibrium. So mathematically, the value, the condition of equilibrium, the equilibrium physical meaning can be described with the equilibrium constant. How to find it? It's coming from two rate laws. Rate law for forward reaction. It's state that rate of forward reaction, rate 1, is directly proportional to the mathematical product of concentration of reactants. In our case, A and B. Why here in this rate law I put it A and B, which is stoichiometric coefficients, balance coefficients. Why not X, Y? Because of doesn't matter how many intermediate for forward reaction, the backward reaction has same number of intermediate. And that's why finally we can accept that if the equilibrium is reached for reversible reaction, it's elementary step, forward and backward. That's why orders are equal to balance coefficient for reversible reaction. Because of we can accept its elementary step. So backward reaction, their own reactants C and D. Rate backward equal to rate constant mu1 because of it's a different reaction. There are different reactants, there are different factors affecting on it. So it's a mathematical product of concentration of reactants C and D in power of balance coefficients, stoichiometric coefficients. Because of, as I told you, we can accept reversible as elementary step reactions. So equilibrium means rates becomes equal. So in this case, right side of this equation also can become equal. Not can, but they are. So from here we can find the ratio K1 over K2. And it's known as a rate constant, equilibrium constant. This ratio K1 over K2. So this is the physical meaning of equilibrium constant. Equilibrium constant can have the symbol Kc with a small c here, mean that it depends on concentration. If there are pressures, like in, remember rate law can be written for pressures. So there will be Kp, but it's equilibrium constant. It shows how many times forward reaction faster than backward if all concentration of all reactants and product equal to 1 mole per liter. So unity. So in such case, rate equal to K, rate equal to rate constant. And that's why this is a physical meaning. So formula of equilibrium constant from rate laws, it's equal to equilibrium constant, equal to the mathematical product of concentration of products in power balance coefficients over mathematical product of concentration of reactants in power balance coefficients. Not correct to say product over reactants. No, products are substances as well as reactants are substances. We can't put substances, physical body, something, in mathematical formula. Here not substance, but mathematical product of concentration of substances. So that's why, again, equilibrium constant equal to mathematical product of concentration of products in power balance coefficients over mathematical product of concentration of reactants in power balance coefficients. And equilibrium constant shows for how many times forward faster than backward. That's why after it found equilibrium constant mathematically found, we can say, we can make conclusion about direction of equilibrium shifting. Now, for example, after we calculated equilibrium constant become equal to 0.5. We can say that backward reaction faster, equilibrium already shift to the left. If the equilibrium constant will be more than 1, we say in forward reaction faster than backward, equilibrium shifts right. It's not a factor shifting the equilibrium. Equilibrium constant shows at the moment which reaction faster, what reaction faster. If equilibrium constant equal to 1, that means it's a perfect equilibrium, ideal situation. Both rates are equal to each other. But equilibrium constant as well as rate constant, never negative, never 0. Can be more than 1, less than 1, or when equilibrium is reached, it's equal to 1, when it's not shifted anyway. And that's why equilibrium constant has no units. It can be because of here different powers, different balance coefficients, different orders. Equilibrium constant has no unit just because of the physical meaning, as it shows for how many times. This means that there can't be any unit. Rate constant they has, depends on order of chemical reaction. Equilibrium constant has no. So equilibrium constant is explain this real situation appears, but then equilibrium is a dynamic. It can be shifting. So we can change some factors affecting the chemical reaction rate and factors affecting reactants and products different way can shift the equilibrium. From all big list of factors affecting the chemical reaction rate, there are just 3 left. Nature can't be changed, it's already happened. So concentration of both reactants and products, both important, because of reactants are reactants for forward and products are reactants for backward reaction. That's why all of them important. They all present in an equilibrium constant. That's why the equilibrium shifts depend on these concentrations also. So temperature factor important because of temperature affect different way on different chemical reactions. Pressure only if there are any gases mentioned. Doesn't matter now left or right side among reactants or products, gas must be there. No gas, no pressure effect on equilibrium. Same as no effect on chemical reaction rate. Catalyst can't shift the equilibrium because of catalyst change the activation energy. And activation energy is a barrier and it's the same for forward and for backward. So what we know, when we use catalyst, we lower in activation energy, but it's the same data as for forward and backward. That means equilibrium will be reached faster but doesn't shift. Catalyst doesn't shift the equilibrium. These 3 factors do. Let us try to understand how. We have the Le-Chatelier's principle. It was from 1884. It's a long time, we know. And it explains how equilibrium shifts because of the stressful factor. So, equilibrium is the lowest energy. That's why if any stress is applied to a system in equilibrium, the equilibrium shifts in a way that tends to undo the effect of the stress. We do something, equilibrium shift to undo this. How to understand this principle. Let us take reaction of formation of urea. Carbon dioxide gas with ammonia in equilibrium reacts forming water and urea. Solid. As you see, one of the product carbamide is solid substance. Heat effect of this reaction is negative, so that means we can say that this reaction, forward one, is exothermic. So let us try to effect this equilibrium, to shift it by changing the concentration. So what we know, if for example equilibrium is reached already, and now I will add a carbon dioxide. When equilibrium is reached, you should understand that concentration of reactants and products stay constant. Same value produced then reacts back. So that's why in equilibrium state concentration are constants. So now equilibrium is reached, we have their carbon dioxide exact concentration present in a mixture, and we add more. So what Le Chatelier's principle state? It states that if we use a stress equilibrium trying to undo the stress, we add a carbon dioxide, equilibrium shift to the side where this concentration becomes lower. Where? In forward. So we add CO2, equilibrium shift forward to undo addition of this carbon dioxide. If there, we will decrease the water, evaporating, for example, after chemical reaction. So what we will see? Lowering concentration of water, we shift equilibrium such way to produce water back. Because of the stressful factor, we lower in something, equilibrium shift to produce it. So that's why it's also help our chemical equilibrium to be shifted forward by lowering concentration of one of the product. Temperature. Temperature effect. So you should understand this. If we increase temperature, equilibrium always shift to the side where this extra heat absorbed. That means temperature increased, equilibrium shifts to the endothermic reaction. Always, according to Le Chatelier's principle. If we lower in temperature, equilibrium shift to the exothermic reaction. Always. The problem for us only to find the proper direction. So in our case, what we see? We see that reaction is exothermic. Exo. So that's why with the temperature increase, the equilibrium, according to Le Chatelier's principle, should be shifted, and it will shift to the endothermic reaction, which is backward. In our case, equilibrium shifts to the left. If I will decrease the temperature, according to Le Chatelier's principle, you should understand that equilibrium will be shifted to the right, to the exothermic, to undo the stress. What about pressure? As I told you, pressure will shift the equilibrium because of it will affect the chemical reaction rate only in one case, if there are any gases are present. So what we see here, yes we do, we have here gases in left and in right side both. So when we change pressure, we change the volume. Increasing the pressure causes lowering of volume. By lowering of volume, we increase the pressure. So decreasing the pressure, increasing the volume. So that's why when we increase the pressure, according to Le Chatelier's principle, equilibrium should shift to the smaller volume of gases. So let us see. Left side of our reactants, for reactant, there's 3 moles of gases. In right side, just 1. Solid substances as well as liquid as well as aqueous will not be affected by pressure effect. They will be not affected. So left side 3 moles, right side 1. We increase pressure, equilibrium should be shifted to the smaller volume, that means forward. If I need to shift equilibrium backward, I will decrease the pressure. In such case, equilibrium shifts to the bigger volume of gases, and it's a left side in our case. If there are no gases, or number of moles of gases, volume of gases, left and right side are equal to each other, we will make conclusion that pressure will not shift equilibrium. We're saying equilibrium doesn't shift. So this is it. For today's lecture is over. I really hope it's the last time you, I don't know, demonstrate such great disrespect to your lecturer as today. Being late because of what you did, it's a real disrespect. For students who joined before, I told everything about what I think about such behavior. And I want to remind you that I'm your vice dean as well as a chemistry teacher. And when you're late, I'm the person who will fight with such disrespect to teachers. Then you complain that you miss information. Then you complain that you have nothing. You can't you can't open something in Moodle. Look how you behave yourself. I gave a lot of useful information in the beginning of the lecture, but you didn't come even. Some of you late almost 1 hour. Absolutely unacceptable. So this is last time. I allow you to be not punished. Next time or next week, if I will see that you late, all names who late, I will write in a piece of sheet of paper and I will talk to your parents. Because of they send it you here, you're sitting in India, necessary to on your computer in time. 9:50 means this is a classroom, this is a lecture hall. I'm here, I'm in medical academy in front of the... So what? Ma'am, the link was sent wrongly. How think? I sent it the link. It's a second room. By whom link was sent it wrongly? I did it myself yesterday. That is second lecture hall. This is second lecture hall. How it's wrongly? Prabhu Kumaran, what are you saying? The link was sent it wrongly. Maybe you used it wrongly. And for everyone, if there any link is posted, evening, I did already everything for all groups except 207. Every evening I told you, I wrote in a WhatsApp what you should do next day. You have all information. If there's some changes, I will post. So you know that if there any new link given, you should try to pass it same moment. If there any problems appears, you should inform your vice dean or lecturer about. Same situation now with the Moodle. Mr. Dmitry made the chat, the group, for those students who suffer because of problems with the Moodle. But every student decided to join them. Does it mean that you all suffer because of problems with the Moodle? And now the group is filled with, there are no more students can be added, but there are a lot of people who have no question. They just pass in the link. But the link there was written, don't disturb your vice dean. That's why it was made, because of if you have problems, you can ask there. Now we need to make the new one and destroy the previous. Because of the crowded, there are so many, internet can't work properly with so many students in a group. This I don't understand. And you write in WhatsApp. You write in, ma'am, it's full. Ma'am, it's full. What can I do? What can I do? Can I sit in a WhatsApp more than 24 hours per day? What do you think about my job? What do you think? We have reception hours. I'm vice dean, right? I'm vice dean. I have reception hours. It's an exact number of hours in dean's office. From 8 o'clock morning till 5 p.m., my country, 5 p.m. I'm teacher. I'm teaching lectures, practical classes. This time I can't answer your questions. I can't, and I will not. My time belongs to group I'm dealing with. For example, now my head of department just now called. I saw he called, but I switched off because if I have lecture, I'm lecturer at this moment. I will not answer. That's why if you evening time didn't pass the link and the problem appears, what can I do now? I will not help you because of I will start to help only when I'll come back home. Evening, it will be 6 p.m. Sometimes I come back 7 p.m. In your country, plus 2.5. Then only I start to answer your questions. You should understand, teachers are not machines. We have job and WhatsApp messages. No, I need time to have a supper. I need to eat something. I have my family to talk to them, to cook, to do something. I have no time because of you sending messages. So that's why let us deal with. We have limit of time. So now it was for 207. Within this week, I will complete to give information every evening. And you should write only if their problem appears. And within 2 hours, from 6 p.m. to 8 p.m. my time. During this time, I will answer your question. Before and after, only if there's something emergency. You understand? Emergency. No, something really happened. If you hear you become sick, you need to inform something. Send. Okay, I will look through when I will have a break. I will look through. Something emergency, I will try to answer same moment I've got this information. So there will be, I hope next week, we will make something as a meeting, same as a lecture right now. For you can ask some question direct into maybe Dean. Maybe you want to ask me about something. I will ask Mr. Verchenko, it's our vice director, who dealing with your contracts and so on. So if you have some questions you ask this, maybe I don't know about when to come back or something. If you have some questions, think about what questions for them. Be short and clear enough. And I will give you link. It's maybe Discord, maybe not Skype, because of Skype will not allow so many students be there. Maybe like this, maybe in YouTube. We will try to communicate and you can ask some questions. And starts from next week, I will make groups for, as a vice dean, groups for communication with me, oral communication, like not the WhatsApp messages. If you want to ask something, you will ask me oral using microphone. I will answer oral, to not type because of it takes time. So, and every group in WhatsApp, I will post the link. Groups I teach, they know what to do because of we use Discord for dialogue, for oral information, and you know how you can ask there something, how you can hear my voice usually good enough, I hope. So, and please think about what are you doing. Online classes means that it's not a self-study and you need to be in time, and class starts, you present in a room. Doesn't matter it's in India. It's small one there. It's separated from surrounding, but it's your classroom. It seems like we're different parts of this planet, but we are same room sitting with a teacher. And teacher gives you information. You share with teacher what you know back, but you should be in time. Okay, so lecture is over. A lot of information. I hope it will be useful. Next week, please don't be late. Be in time. And I will think what lecture better for you next. For thermodynamics and Moodle, the information is given. I will try to check why it's not opening, but it's possible. So for third class, you have all information to be ready. We'll see. Okay, goodbye. See you, my group, see you practical class. 12 o'clock, don't forget. Goodbye.